Ignore the fact that they're not in order and that there are duplicates of them. I'll clean them up real fast. I've opened the quizzes, so it'd be appropriate for y'all to have done quizzes 6 and 7 in the next couple of weeks, maybe by spring break. We're starting chapter 9 today, so, you know. The way the quizzes work is you take them, I grade them, and then you can revise it so that you can get a better score. And when I say revise, I mean retake. But unless the quiz is entirely multiple choice, which it's usually not, I have to grade them by hand. But I'll try not to let too much of a delay accrue. Okay, so I want to talk about arrays just a little bit more. See if I can pop open a picture of a 2D array. That'll work. Google has recently made their image search a lot more annoying. You can't just click on an image and have it open it up. All right, so there we go. We have a two-dimensional array here. What if we wanted to get all of the values in a row, or all of the values in a column? Well, this picture gives the game away, right? You would loop through it if we wanted the third row, and we would kind of treat it like a single-dimensional array, right? We would get item 3, 0, 3, 1, 3, 2, 3, 3, 3, 4, and 3, 5. Guess when I'm pointing on the board, the people watching at home aren't going to see it. And if we wanted to get this column, we would do it at 0, 4, 1, 4, 2, 4, 3, 4, 4, 4, and so on. So let's write itty-bitty little program that would do that just for like a 4x4 array. Like if you're going to write a 4x4 tic-tac-toe and you wanted to see if somebody had filled in all the rows or all the columns. And we can do that. So let me open NetBeans. The idea is going to be that if we check an entire row, all the column numbers are going to be the same. And if we check an entire column, all the row numbers are going to be the same. So if we were awesome, we'd fill the thing with random data or whatever, but we're just going to create, with an initializer, a two-dimensional array when it comes up. And by the way, if y'all haven't taken C#, I hope you'll take the C# class. Really cool language. We do programs that are actually kind of more fun than these. I need to start bringing some of those into here. And although it's a online class, I usually meet once or twice a week just to bring students in to record the videos. So, you know, might like it. Strongly encourage you. One cool thing about C# is that it is more GUI oriented from the ground up. You can create GUI applications very, very easy. So if I was going to make a two-dimensional array, I would first increase the font size. I hope that's legible. I'm going to go up. Alright. So declare an array. Why don't we declare it as a static array so that multiple methods could access it? So, static int equals, and let's fill it in with some data. Remember that a two-dimensional array can be considered an array of arrays. So watch what I'm doing here. I'm making 4 rows. Whoops, that was supposed to be a comma. Of braces that I'm then going to fill in with extra data. Well, with initializer data. Alrighty. So 0, 1, 2, 3. Well, okay, I messed that up. 2, 2, 4, 3, 4, 4, 4, 4. I'm trying to make it so that one of these, okay, I goofed. I wanted one where they had a column that all matched and a row that all matched. So that's what I'm going for. Whatever numbers you pick. I forgot to give the array a name. Static int, double pair of braces, grid. All right, so now I have a name for it. It's a two-dimensional array, 4 rows, 4 columns. I'm a totally cheat and create 2 members. That are rows and columns. So final static int rows equals 4. Final static int calls equals 4. Is this good programming? No. Those ought to be determined, programmatically, perhaps in the constructor for the class. But it is what it is. I don't want to spend too much time making a perfect program. I will just comment the parts that are bad programming. Okay, so I want to see if row 0, if all the elements of row 0 are the same. Here's the dumb way. Don't type this because it's the dumb way. If grid 0, 0 is equal to grid 0, like I said, don't type this, 1, and element 0, 0 is equal to 0, 2, and element 0, 0. Okay, right. You want to do it with a loop. We could conceivably and probably should stick this in its own method so that we specify row 1 and it'll go and it'll find out if row 1 all the values are the same. So let's do that. It's going to be a Boolean. Boolean row same, and you specify which row. I'm going to put a return true at the bottom because the way I'm going to write this code is if it finds a mismatch, it returns a false. But if it gets all the way through the loop, it meant that they all matched. First thing we ought to do is validate that that row is an acceptable row number and throw an exception if it's not. First, we check to see row is valid. We're skipping that. How would you do it? You just make sure that row is less than the number of rows, right? As long as this row is less than the number of rows, it'd be good. Okay. Now we're going to loop. While guess we ought to put a counter in. So int column is equal to 0 because we're going to check all of the elements in that row, every column in that row. And we're going to count column from 1, 2, and 3. We could also check 0 against itself, but 0, of course, is going to be, well, just for simplicity's sake, I'm going to start it off at 0. So int column is equal to 0. For, in fact, why not just make it a for loop? For int call equals 0, call is less than calls, call plus plus. What are we going to do? We're going to check each one against the first element. So if that one's equal to that one, great, keep going. But if it's not, return false. If that one's equal to that one. And then if that one's equal to that one, yeah, you could do some tricky stuff where you're comparing it to the one right before it, but meh. Okay, so if our grid at row, comma, column, I'm doing that right, not column, that's C++ style, like that, there we go, is equal to the first element in that grid. But instead, I actually want to make sure it's not equal because I want to be able to return false immediately. So if grid row call is not equal to grid row column 0, then return false. If it gets all the way through it, then it means that it never found an invalid value. Now what's an optimization for this I could make? I could eliminate one of the checks, speed it up. In this case by 25%. And a larger one, it wouldn't be that big of a savings. But why would I compare element 0 against element 0? So I should theoretically actually start the column at 1. Let's see if it works. So down here in main, Boolean match 1 or match row 1 is equal to row same 1. Okay, should I have started it at 0? Yeah, I should have. Okay. So 0, 0, and I'm not doing C++, so I need to spell out the entire word Boolean. I've still got a problem. What? Anybody spot the error? I don't. Non-static method. I forgot to declare set row same as a static method. I should probably pass the array in. Write this a little bit more genericized so that we can pass the grid in, and static has to come before Boolean. All right. So static Boolean row same. That works. And then let's just put an if statement, or let's just print it out if it works. Okay. So system.out.println row 0 all the same, question mark, plus let's just print out that variable, match row 0. Didn't repeat those things, you know. Really this ought to be a loop, right? But it's, for this case, it's easy enough to copy and paste. So match row 1 is equal to the row same 1. I'm just changing all the 0s to 1s there, all the 0s to 2s there, and all the 0s to 3 there. And by the way, oh, and down here, so there's 3 numbers to change on every row, 4 numbers to change on every row, on every print, every pair of comparisons. I'm going to give y'all extra credit, which is to modify this code to check to see if the diagonals are all the same. Your code ought to be a little bit more elegant than mine here. If you were going to check, you know, that ought to be a loop. But anyways, I'm going to see if this works. And then I'm going to make sure that you all got it typed in, because I went perhaps fast. And it didn't find any of them to be true. That's too bad. Let's go back up and check our data. Oh, well that's true, right? I don't have anywhere they're all the same. Let's make the last row all the same. 2, 2, 2, 2. All right, and it did work. Okay. I want y'all to spend like 2 minutes thinking about how you would change row same. Copy and paste it into a method called call same. And what change would you make? It would be like 3 or 4 changes. I'll wander around, make sure I have no typos. Yeah, I'll start it off. Copy the row same method, paste it, call it call same, like the entire column's the same. Modify it so that you pass in the column rather than the row, and then make the other changes required. Just a thought process. Instead of checking an entire row, you're going to be checking an entire column. And it's okay if you don't get it. I'm going to show you like in a minute and a half. Cool. Don't do the extra credit right now. Somebody waggle their eyebrows if y'all have got the idea.
So you want us to, so for the extra credit, you want to run both column and row?
What I wanted to do for the extra credit is just check element. Let me scroll back up to the little array. That one, that one, that one, and that one. If they're all the same, print true. And that one, that one, that one, that one. If they're all the same, print true.
Okay.
Eventually you could get around to writing Minesweeper, right? Where you check, you count it, how many elements, around them. If you were ever next to a mine, it'd blow up. That's kind of a fun little game to program. All right, so what I would do is if I'm passing in the column, then I'm obviously not going to iterate through all the columns. So I would just change that to row. So for column same, I check my change my for loop for row is equal to 0. Row is less than the number of max rows. Row plus plus. And this syntax is still okay. But I'm not going to check row comma 0 every time. What am I going to be checking instead? The first element of the column. And what is that? Yep, so because the first column is 0. Excuse me, the first row is 0. Now that ought to work. I don't even think that I want to go and I guess I better check it. What's our row that matches? Excuse me, our column that matches. None of them do. Oh, here we go. Column 1 is supposed to match. So, system.out.println. Column 1, the same, question mark, plus call same one. Right, I just shortened that a little bit rather than cache it in a temporary variable. And I'll scroll it back up if you need to write that. Get that function down. All right, it said column 1 was the same. I'm going to change it to column 2 just to make sure that it goes false. I could copy and paste that 4 times. Why don't I do that? Not going to take long. So 0, 1, and 2, and 3. Now you are a bad programmer if you copy and paste rather than writing loops. So I am a bad programmer. All right, so I had one column and one row in my data that were all the same. If you mucked with your numbers, you might have different results. If you made them all the same, then every time it would say all, we'd get all 8 trues. Anybody need the same call function back on the screen? I better scroll back up for the folks at home. Here's what same row looks like. And then here's what same call looks like. Another thing I'd really love to do, but we have other material to get onto. It's something that I haven't taught other classes, but it's come to my mind recently. Oh, by the way, we're going to be offering a data structures course, probably in the fall. Data structures is a cool concept. I think we're going to teach it in Java. There's a little bit of discussion about whether it be in C++ or Java. Much more in depth than the style of programming that we're doing here about technical stuff. How to write linked lists, things like that, rather than just use the library that's given to you. So, how to write trees and do a sort on a tree rather than just depending upon somebody else's sort algorithm. So we all good on this one?
Is there like a purpose why we switch these two out? Or you get 0 there? Like in this one?
Yeah, I'll tell you that in just a second. Where are we getting some boom on that one? What's that error up there? Storage expression. Oh, you probably just need a closing brace. No? We need one more closing brace and then a return true. So, put your cursor there.
Oh!
Return true, then close. Just a copy paste error. Got yours rocking? Cool deal. All right, so why did we swap the 0 from the second position to the first position here? That's because when we were checking here, we were comparing every element in the row to column 0. That one is the same, that one's the same, that one's the same, that one's the same. So we were iterating the column number. So we were iterating the second value. Excuse me, the first value. The first value is the column and the second one's the row. So that's why we had the 0 there. But when we wanted to check the entire column, we compared it against the first row. Compare that one, that one, that one, that one, and so on. So since we were checking against the first row, the row is the second value in the series. No, it's the first value in the series. I keep getting them swapped. Sorry about that. Anyways, does that make sense? Why you did 0 on each? Okay, why you swapped them. Cool. Alrighty. Onward to other topics. Array lists. Array lists are cool because of the limitations of arrays. Drawbacks of arrays. One, I'm just going to say it's the huge one. Now I'm not going to even enumerate it. Fixed in size or length. That's what arrays are. You declare an array to be 10, it's going to stay length of 10. What if you fill it up with 10 pieces of data? Well, either too bad, or you have to allocate a new one, copy all your old data into it. What if you want to delete something from the middle of the array? Well, are you just going to leave like a 0 in the middle of the array? Or are you going to copy all the elements, one back in order to fill in the gap? They are not dynamic, so they're fixed in length. They are not dynamic. Appending items past the end of the array is a real problem. In other words, growing the array. And 20 years ago, when you took programming classes, you wrote a lot of code about how to remove things from the middle of an array or how to, grow the array. But nowadays, all these things come with libraries. All these languages come with libraries that have been, tested by millions of people, so you don't wind up, So, deleting items from the middle of the array, another real problem. To grow an array, you have to allocate a new array. Copy all the elements one by one into the new one. That makes sense? That's the problem with arrays. Hopefully you have done enough array stuff now that makes sense. So, the solution, ArrayLists. ArrayList, the ArrayList class is dynamic, meaning it will grow and shrink as you need. You don't say, I want an array list that can hold 10 elements. Instead, you say, I want an array list. It starts off empty, and then you start adding elements onto it, and then it's length. Because if you call .size on an array, it's always going to return 10, because that's the size of the array. But if you call ArrayList.size, for some reason they didn't make it length, it's going to only return the current number of elements in the array. So, and this is really cool. What if you didn't know how many customers you were going to have that day? If it was Sunday and your store was closed, you might have no customers. If it was Black Friday, you might have 10,000 customers. Would you want to allocate an array of maximum size 10,000 in order to hold the maximum size? If you're, what if only 5 customers came in that day? The rest of the memory would be wasted. Instead, you'd want to use an array list that would grow and shrink to accommodate the size necessary. So, comparisons in how you allocate an array. Here's how you allocate an array. The data type doesn't have to be an int. You know that, but I'm not going to just put type there. So int, array is equal to new int, and then you specify a size. Here's how you allocate an array list. Except you cannot use the int data type. Let me go back. ArrayList is what's known as an abstract data type, meaning it can hold different types of data. You can make an array list that'll hold floating point numbers. You can make an array list that'll hold turtles if you're using some kind of turtle graphic program, int, strings, floats, whatever. But they cannot hold primitive data types. The abstract data type can only hold other classes. So they must use classes, so-called reference types. Meaning that if you want an array list of ints, you have to use the wrapper class. Same for, double, use double. Now a string is already a class, so you don't have to do anything special to use a string. Okay, my brain just did a flip. Is it actually int with, yeah, it's the whole word. Okay. So here's the array list. You actually use the class name. I want an array list of type integer is equal to new array list. You specify the data type again, and then you invoke the constructor by doing that because the array list is itself a class. Now notice we have this duplicated word here. So a long time back, about 10 years ago, they changed the compiler so that you can leave that out and it'll figure it out. So there we go. That's how you declare an array list. Notice it's not fixed in size. So we know how to change elements in our array. You know, element 0 is 10. Element number 1 is 20, and so on. To do an array list, a list dot append, and I better double check because in some languages it's dot add. I'm going to append a 20 to my array list, and then a list dot append, you know, or 10 and a 20. Okay, so now I have two pieces of data. I'm going to change the size to an actual, you know, number. So if we tried to print it's length, isn't it? Yeah. If we called array.length, we would get 10 at that point. Right? Because it's always going to be 10. That's what we allocated it to. But if we call what is a list.size, like I said, notice that they gave it a different name. It's going to be 2. Let's go look at the PowerPoint. Wrong one. I'm in the wrong class. Ooh, we've already finished chapter 9. I forgot that this new version of the book breaks array lists out of chapter 9 into chapter 10. So we're a little bit further along in the book than I expected. In my quizzes, I don't ask questions that I haven't covered, so the quizzes are not exhaustive to the chapter, they're exhaustive to what I teach, if that makes sense. So an array list. It's part of the Java collections framework, meaning that there are a lot of other data types as well as array lists. How many of y'all have heard of dictionaries? Yeah, you took a scripting class or whatever, dictionary. There's a data type that is equivalent to the dictionary. There's a couple of different versions of that. And there is another one optimized for being a queue. You put things in on, you know, one end and then you retrieve them from the other. And there's another one for stacks. So the array list provides a basic functionality that comes with a standard array and additional functionality. The basic one, it stores an ordered collection of values, meaning that, you know, if you insert 3 things in order, then 0, 1, and 2 are going to be, you know, in the same order. And you access them via an index, just like you do with an array. But what's cool about it is it grows and shrinks dynamically. So in order to get it to work, you have to add an import, java.util.ArrayList. Let's see if we can get this working. I'm going to go back to our code. I'm going to stick this stuff at the top of main to make it easy to find. And looking at this font, I probably ought to bump it up a size. All right. So array list int, has to be a non-primitive data type, has to be a reference type. Array list integer. I think I'm going to call it iList because it's a list of ints, right? Is equal to new array list. You don't have to specify the type through the second go around, but you do have to invoke the constructor. Is there anything you can pass into the constructor? Good question. I'd have to go and look. Alrighty, it says cannot find symbol, and that's because I have not done a import java.util. I'm going to cheat and let NetBeans fill that in, but you know from past experience that if you wanted to go and add it yourself, you would scroll up to the top and do import java.util.ArrayList with a capital A and a capital L. Alright, so back down to main. Let's add a few elements to our array list. I got lost. Where'd main go? Main is right there. Okay. So IList dot, and it is add. Did I say it was append in my notes? All right. I was wrong. Okay. ArrayList.add, ArrayList. Okay. So, IList.add, I'm going to add a 3. And I'm going to add a few more numbers. A 6, a 9, and a 12. Whatever, they could have been anything. How do you get them back out? With .get. Write a little loop. And yes, you can also use a for each loop to do this. So, for int I, being our index counter, is equal to 0, keep going while I is less than the size of the array, so ilist.size, parentheses in parentheses. Keep adding 1 to I each time. Let's print it out. System.out.println ilist.get that specific element. Right? You would call get parentheses 0 to get the first element, get 1 to get the second, get 2 to get the third, get 3 to get the fourth, and if you called get 4, it would blow up because there's only, the highest index value would be 3. You're familiar with that concept from arrays. You go past the end of the array, you get an exception. Alrighty. I'm going to run it. And there we go. It prints out 3, 6, 9, 12. Let's delete one of the items. I need to remind myself of what the methods are called so I don't make the same mistake. So I'm going to highlight the word ArrayList, show Java doc, look at the methods, add. There's a second version of add which allows you to insert it into the middle of the array. We will demonstrate that in a minute. Get, we've seen get. There's another one called isEmpty, which is almost superfluous because you could also ask if it was the size was equal to 0. But alrighty. Then there's remove. Remove has 2 versions, which is slightly confusing. You can remove either by index or you can remove by value. The way it differentiates between a behavior is that removing by index, you specify the index number as an int. If you remove by value, you pass in the value. But since your value can't be an int, that's how it distinguishes them. Okay, so back to our code. Let's remove one of these guys. Maybe the first one. ilist.remove 0. If we printed out the length now, the length would be 3. Again, I'm going to be lame and just copy and paste my print loop. So I highlighted my print loop and I pasted it. Now when I print it out, it should just say 6, 9, 12. Alrighty, and it did. It printed 6, 9, 12. Now you can also use .add to specify or to insert into the middle of the list. And the way you do that is you specify the index value that you want that one to be. So ilist.add, I want this new element to be 0, element 0, or element 1. Since we've removed 3, the array list is now 6, 9, 12, and then if I add a new one that I specify as being 1, then it'll be 3, whatever that value is, 9, and 12. So I'm going to insert a 20 into the array list at that point. Notice that even though it's an array list of wrapper types, due to the magic of what's known as boxing, it goes ahead and converts that int into an uppercase I integer. Now let's print it out one more time to make sure if my prediction was correct. It should say, the 3 is missing, right, but we still have the 6, 9, and 12, so it should say 6, 20, 9, and 12. Yep, 6, 20, 9, and 12. You see how that works? If you call .add with only one parameter, it appends it. If you call .add and you specify what index value you want to be, it pushes everything down. If you specify an invalid index value, I'm going to just goof off and change that 1 to a 10. It should generate an exception, and so it did. You can't insert past the end of the array. If you want to insert past the end of the array, then you better call .add without an index number. Alrighty. So what is our homework going to be? Don't start working on it. But what I want you to do is create an array list called colors. Fill it with the colors of the rainbow. Go ahead and put them in caps. Just make it easy. Print the list out. Remove the second color. So the colors of the rainbow are Roy G. Biv, red, orange. So remove the second element so that orange is gone from the list. And then insert at the beginning of the list the color black, and insert as the fourth element, which is index value 3, right? The color white. Click the list again. Is there a shortcut for printing the array list without you having to use a for loop? Well, yeah. But firstly, let's do a for each loop. Just makes it a little bit easier. So up here, where I was printing my array list out, for every integer I that is in the array list, just print it out. System.out.println I. And my brain just totally froze on how to call the function that'll convert the whole thing to a string. Of course, when I hit Stack Overflow, there'll be a spirited argument and 20 solutions. String builder works. Okay, that's cool. I do want to demonstrate that one. That one's cool. Using a string class. Okay, let's make a string that contains that stuff. So string, IList string, is equal to string dot, make sure I got the syntax right, join, string dot join. I want all the items to be separated by commas, and the name of the list that I want to join is IList. And it's blowing up, so I'm not going to spend any more time trying to work on that. Did I get the order wrong? No, forget it. Was supposed to work. Didn't. Don't want to spend any more time on it. Alrighty. Extra credit. Find a way to convert the array list to a string with one call. Because you could write a for loop, right? And then just keep appending every element. I just don't remember the call, so I'm going to leave it for you to research. Why not just print ArrayList.toString? Well, let's do that. System.out.println ilist.toString. It's not. Okay, it's possible it actually is going to work, despite my. Okay, forget it. No extra credit there. Sorry guys, my brain flopped over from C# coming back into here. So I'm going to take that out. Okay, so that's a fast way of printing it out. I want you more, it's more important that you know how to print it out with a for loop or for each loop. No, I won't say that. Conceptually, I want you to know how to do, the for loop or the for each loop. But when you're printing for just debug purposes, just calling print line and using toString, and remember you can always eliminate the toString part. Cool. Thank you, Java, for doing it that way. Then what am I thinking of? It's arrays that you cannot print out that way, right? Because it just prints the address. Something like that. Forget it. Alrighty. Really wanted that to work. Alrighty. So here's how you create the array. Array list element type. Element type has to be a reference type. Variable is equal to new array list. You have to invoke the constructor. Be interesting to see what you can pass into the constructor. Worth researching. Can you pass in an array and have it build an array list based on that array? Can you pass in another array list? Let's play with that one. So right here I'm going to try to make a new array list. Array list IL2 is equal to new array list. I forgot to specify the type. Array list printed, diamond bracelets, brackets, integer, in the brace, IL2 is equal to new array list. But I'm going to pass in the original IList into the constructor. See if it makes a copy out of it. Well, it compiled. I expect it'll work. Why would you want to make a copy of it? Why would you not just want to do this? IL2 is equal to IList. What's wrong with doing that? Was that a good idea when we were doing our own class objects? Let me reword it. Why did we not use equal to compare two objects? Yeah, because it's just a reference to the same memory address, right? And so this just copied that memory address into IL2. So if you do any appends to IList, and then you look at it through IL2, you see that new data. They're really just pointing to, two street signs pointing to the same house. So instead you want to perform a copy. I'm going to try to prove that these are copies, or not copies, by removing something from the second list and then printing them both out. So IL2 dot remove. I'm going to remove element 0 from IL2, and then let's just print them out again. System.out.println ilist plus IL2, like that. And I'm getting an error there. Bad types for binary operator plus. It's not converting them to a string. Okay, fine. Print them on two different lines. Alright, so when I printed them twice, the second one, IL2, has the first item missing and the first one did not. So they are separate arrays. Excuse me, separate array lists. Why would stuff like that be important? Well, what if I asked you to write code that would sort an array list, but you wanted to keep the original random data so that you could call another algorithm on it to see if it was more efficient or not? Well, you make a copy of the array list, and and then you do all your changes on that one, but you still have your original hanging around so that you can make another copy of it. All right, I think that's about as far as we're going to go on ArrayLists today. Adding elements, we've seen that, .add. So the Java API, that's the application programming interface. It's the interface to the huge library of pre-built Java classes. As a programmer, you don't need the internals. We don't need to know how ArrayList works. We just need to know how to use it. That's a good example of abstraction. They've made an incredibly useful class. And trust me when I say that people in the 70s and 80s would spend a lot of time writing these things themselves because there was no universally accepted library. I did start the recording, did I not? Yay, alrighty. So this is going to actually be E, F, G, H. There's one more video that I want y'all to watch. It's about two-dimensional arrays, so it's not as critical that you watch it timely because we've kind of just moved on from two-dimensional arrays. I'm not even sure I gave you an assignment over 2D arrays. But do get it done.